Hello, today's video is on 12.2 and we are going to be looking at combinations. The first thing that you probably think about is your locker combination. That is actually not a true combination. Your locker combination is actually a lie. So we're going to start by warming up and thinking about what we did yesterday. You have 6 paintings that are entered into an art contest. How many different ways can the paintings finished first, second, and third? So if we have 6 paintings, but we want to know how do they finish first, second, and third, for first place there are 6 paintings up for grabs. Any 6 of those can make first. Whichever one makes first is no longer in the running for second place, so we've got 5 options for second place, and we've got 4 options for third place. Or you could have remembered our little formula there. We've got 6 and we are permutating that 3, so we want to choose 3 out of those 6, which gives us 6 factorial over what will end up being 3 factorial. Any of those options are still going to give you 120 different ways. So if you have 6 paintings, we've got 120 different ways that different paintings can finish first, second, and third place. With permutations that we talked about yesterday, the order was going to matter. There is a difference between first place and third place. With combinations, the thing that you want to remember is that order is not important. So entering first, second, and third in a race is a permutation. We would not use our combination formula. Our formula for combination, as you can see, is very similar to our permutation, n factorial over n minus r, but we're going to multiply it by r ways. So 3 paintings are going to be chosen to be displayed in the gallery from a pool of 6 different paintings. How many combinations of 3 can be chosen to display? So here, order doesn't matter. We're not in a contest. We're not going for first place or second place or third place. All we want to do is pick any 3 of those paintings to put them up on the wall. It doesn't matter who goes up on the wall first and who goes up on the wall last. They're still up on the wall. So we've got n is 6 because we have 6 total paintings, and we are going to choose 3 of them. If we go into our formula, we've got 6 factorial divided by n minus r. Our n is 6 minus our r, which is 3 factorial. And then our new part is we're multiplying it by r factorial, and 3 is that r. So you could go ahead and do this. 6 factorial divided by 6 minus 3 is 3 factorial times 3 factorial. You can type all of that into your calculator, or just like yesterday, there is a shortcut on your calculator. So in our calculator, if we hit the math button, we arrow to the probability. Yesterday we did the NPR. Today we are doing combination. So number 2 is for permutations, number 3 is for combinations. Just like yesterday, it's NCR. We have to enter our n value in first. So we go back to our home screen. We have 6 and we are choosing 3. Again, make sure that you put that 6 in, then you go to your math probability, NCR, 3. We're choosing 3 out of those 6. We hit enter, and there's only 20. So from our warm-up problem, we were choosing how many different ways we could do first, second, and third. So it mattered who went first, who went second, who went third. We had a whole 120 different ways that could happen. But when we look at the combinations, when it doesn't matter who's first, who's second, who's third, if I take any of those in any order, it's still the same combination of paintings. We only have 20 options. So we have a lot less options when we're looking at the combinations when order is not going to make it special. Alright, so let's move on with some other kinds of combination problems. There's going to be lots of problems that have to do with cards and decks. And I know that not everyone is familiar with playing cards. You will have questions about cards on your quiz. So these are the things that I expect you to know. So if you didn't know them before, that's fine, but you need to know them now. You're going to have lots of questions on what is contained in a 52 deck card. So what you have to know is that there's 4 different suits. There's 2 red suits and 2 black suits. The red suits are hearts and diamonds. The black suits are clubs and spades. Within each of these suits, there are 13 cards. So there's 13 diamonds, 13 hearts, 13 spades, and 13 clubs. Within those 13 cards, you're going to have 1 ace, the numbers 2 through 10, and then 3 face cards. The face cards are jacks, queens, and kings. So all of this is extremely important. You can't come to your quiz day and then you have a question on it and come ask me, how many queens are there? How many cards are there and how many hearts are there? Those are something that I expect you to know for the quiz. All right, so order is not important. And since we know order is not important, we are going to be using a combination. That is how to distinguish between using permutations and combinations. How many different 7-card hands are possible? So we think about, we have NCR, where N being the total number, R is how many we are choosing. Well, in a deck of cards, there are 52 cards total, and we are choosing 7 of those cards. So if we plug that into our equation, our formula, we've got n factorial on top. On the bottom, it's n minus r factorial times r factorial, which gives us 52 factorial divided by 45 factorial times 7 factorial. Also remember, you can just go directly to your calculator, type in 52, then you hit the math button, arrow to the probability, choose the NCR, and then hit 7. Do we need to see that again? Alright, so get out your calculator. Okay, so we type in 52, we go to our math button, arrow to probability, we have combination, so we want number 3, NCR, and we are choosing 7 cards, any 7 cards out of that 52 card deck. And we get a total of 133,784,560 different card hands that we can get. That is a lot. Alright, number 3. How many of these hands all have 7 cards of the same suit? Okay, so now this is where it's going to get tricky. You really have to think through your process. So I'm hinting to you, the first card sets the tone. So we think about the fact that we have 1 out of 4 suits. Remember, there's 4 suits: hearts, diamonds, clubs, and spades. So the first aspect of this is we have 4 suits and we are choosing 1. Then we have to consider the fact that we only want to choose from that given suit. So we want all 7 cards to be either all hearts, all spades, all clubs, or all diamonds. And from that we know that we want 7 of 13 cards. There's 13 cards in each suit and we want 7 of them. So we're going to multiply that by 13, choosing 7. So we have to type this into your calculator. You can do it by hand, but probably at this point you don't want to do it the long way, you want to do it the short way. So we've got 4, math, arrow to probability, number 3, and we are choosing 1. Remember, that aspect of the equation is taking care of the fact that we are choosing 1 out of our 4 suits. and then we want to choose 7 of the 13 cards. So 7, math, arrow to probability, number 3. Oops, I made a mistake. We are choosing 7 of the 13, so it's 13. And then 7. And we're going to cut it down significantly. And if we want to choose 7 of all the same suit, we went from 133 million different ways to do that to 6,864 different ways. So the more specific that it's going to be, the less ways that you can do it. All right. Let's turn over to the back page of that note sheet. When we are doing combinations, sometimes you're going to add, sometimes you're multiply, sometimes you're going to subtract. When you are reading the problem, you are going to add if the number of ways you're considering of an event is A or B. The key word being or. If I said you want to choose a heart or a club, or I want to choose a jack or a queen. If the problem is stated of 2 events, one or the other, you're going to add the combinations together. When you multiply, it's when we're considering the number of ways of an event. If I say I want A and B. So if I want 2 hearts and 3 spades. So the key is, how is it being phrased? Do you want one or the other, or do you want both? And we'll come back to subtraction in just a few minutes. So on vacation, you can visit as many as 5 different cities and 7 different attractions. Suppose you want to visit exactly 3 cities and you want to do 4 different attractions. Well, there are 5 different cities total. We want to go to 3 of them. So that would be 5, choose 3. Our key word here being and means that we are going to multiply that by 4 different attractions. Well, there are 7 attractions we can choose from, so that is 7, choose 4. Go ahead and pause, enter this into your calculator, and see if you can get the right answer. Remember, it's really easy when I'm sitting here telling you, oh, this is the answer. It's another thing for you to actually be able to go through, know where the buttons are on your calculator, and be able to get the answer on your own. So make sure that you are pressing pause and you are finding the answer. All right, and you should have gotten 350 total possible trips that you could have made up there. Again, remember the keyword being and meant that we were going to multiply. For number 5, suppose you want to visit at least 8 locations, cities, or attractions. How many different types of trips are possible? So you want to visit at least 8 locations. Again, the hard part about this is actually reading the problem and knowing what you're looking for. Knowing that at least means that I could visit 8 or 9 or 10 or 11 or 12. The reason why we have 12 possibilities is because we have 5 different cities, 7 different attractions. 5 plus 7 means that we have 12 total cities and attractions together. So if we want to visit at least 8 locations, it doesn't matter if it's a city or an attraction, we have 12 things that we are pulling from. The word at least means that we're going to have no less than 8. It's either 8 or more. So we could have 8 or 9 or 10 or 11 or 12. The fact that we have the word or means that we are going to add them together. We have a total of 12. We could choose 8. We could choose 9. We could choose 10. Or we could choose 11. Or we could choose 12. So we have all of these different possibilities that we could do one or the other, so we're going to add those together. Lots of different strokes that you have to enter into your calculator. Take the time right now to press pause and enter them in. Alright, after you've entered those in, you should have found that there were 794 total trips possible if you're going to do at least 8 locations. Okay, we're almost done. Okay, for number 6, from the list of salad toppings, how many different salads can be made? So we have bacon, tomatoes, croutons, cheese, mushrooms, and chicken. That means that we have 6 total options. How many different salads can be made? There's no restrictions, so we could have 0 toppings, or 1, or 2, or 3, or 4, or 5, or 6. So if we do this the long way, we've got 6 choose 0, 6 choose 1, or means that we are adding those together, all the way until we get to 6 choose 6. So we could either have no toppings on our salad, or we can have all 6 toppings on our salad. When we enter this into our calculator, we are going to get a total of 64 different salads. One thing that's going to get a little bit tricky as we move on and get into more difficult problems is there's lots of different ways that it can be approached. I can also think about this as each individual topping. I've got bacon, I've got tomatoes, I've got croutons, I've got cheese, mushrooms, and chicken. I have 2 options for each of them. Is it yes or no? Yes or no? So there's 2 options for bacon, 2 options for tomatoes, 2 options for croutons, 2 options for cheese, 2 for mushrooms, and 2 for chicken. So this can also be thought about as 2 to the 6th power, which is also going to give you 64 total different salads you can make. On a quiz or test, it doesn't matter which way you approach it. Some people just think about it from a different angle. So you can think about it's either 1 or all the way up to 6 toppings, or you can think about it from a toppings point of view. Is it a yes or a no for each individual topping? Our last problem. On a deluxe salad, you can have up to 4 toppings. How many different combinations of toppings can you have? Again, this is where reading comes into play. If I'm going to have up to 4 toppings, that means that 4 is the most. So I could have 0, or 1, or 2, or 3, or 4. Anything up to 4, I'm not going to go beyond 4. So what's left? It's either 5 or 6. Those are the only 2 options that we're not taking into consideration. So we can do this of choosing 0, choosing 1, choosing 2, choosing 3, or choosing 4. And when we enter all of that into our calculator, we get 57 different salads. But there is a faster way to do this. If we have up to 4 toppings and there's only 6 total, we can do it this whole long way of 0 or 1 or 2 or 3 or 4. But if I think about what's left, there's only 2 options that I'm not considering. So what I could do is take the total options, which we found in number 6, which is 2 to the 6th, yes or no for each of them. There's 6 toppings that we're considering, and I can subtract the 2 that we're not using. Okay, so we can either add up everything that we're getting, or we can subtract what we're not getting. So that would give us 64 minus 7, which leaves us with the exact same answer that we got from up above. The only time that we really use subtraction is if what's left is significantly less than how many we're trying to find. So if I'm trying to make a salad and there's 20 different toppings I could add on my salad, and I want all of them except for 2. It doesn't make sense to add up 18 different options when I could just take the total, subtract the 2 that I don't want. So if we go back up to the top of our page, subtraction. We only use subtraction when the number adding is more than what's left. And again, that you don't have to subtract, it's just a shortcut for subtraction. Okay? And then we are done for today.